Wait, my solar panels are making power at night? A few days after my Powerwall installation was complete, I noticed something strange. Many nights, in the middle of the night, the Tesla app showed that my solar panels were producing a ton of energy, like 3 times as much energy as my entire solar array can produce even at noon on a sunny day. Also, during the day when my panels were actually producing, the solar production numbers reported in the Tesla app were incorrect a lot of the time. A few months later, I noticed that our electrical usage was way too low for a family that charges EVs at home. I couldn't get Tesla Energy to help, and this is the story of how I fixed this myself. You might rightly wonder whether this is even worth fixing. Like, isn't the system functioning properly and just showing incorrect data on a weird animation? Well, no, not really. One result of the system not metering electricity correctly is that when we would lose power, it couldn't give us any remotely accurate estimate of how much time we had left before our batteries were empty. Also, it would charge the battery at weird times when power was expensive instead of from solar. So it's not just nice to have. It's pretty fundamental to correct operation of the system. Tesla Energy itself installed my Powerwall batteries and backup gateway. And I should mention here that I was super happy with the install, even if it was more than 2 years after I placed my order. The installers were friendly, answered all my questions, were extremely professional, and were flexible with install location. The install turned out super clean. And now, having spent hours inside the Tesla Backup Gateway and understanding how it's built and how it works, I continue to be impressed with the quality of Tesla's engineering. As you may know from my other videos, I'm a Tesla product fan. Tesla support, Tesla service centers, not so much. Anyway, since Tesla Energy itself installed my system, I reached out to them for support. After explaining my problem, Tesla Energy support refused to help because my solar panels were from Sunpower. Now, don't get confused here. This Tesla Backup Gateway doesn't care if the electricity it gets is from Tesla, Enphase, or Sunpower panels. In this particular gateway, it all just integrates after going through the microinverters as AC. Tesla Energy's published gateway installation manual makes this abundantly clear. Not supporting an install because of Sunpower panels is nonsense. So again, it was up to me, the Tesla product owner, to troubleshoot another one of Tesla's products on their behalf. This video details my saga of how I figured out what was wrong with the install and how I fixed it. But I need to say one thing clearly up front. It is incredibly dangerous to get into your electrical panels or the Tesla Backup Gateway. Don't do it. In many cases, it's also unnecessary, as I discovered. But with what you learn in this video from getting to look inside my panels through a screen, you'll be able to troubleshoot and probably fix your system without getting into any of your electrical equipment. If you figure out that your system does require physical changes, you'll be able to communicate knowledgeably with an actual, capable electrician who can do the work without killing or injuring themselves, like you might. In my case, I finally became curious enough to fix my system when I stumbled upon the answer to what was causing my system to think it was producing solar at night. One fine evening, I was in the Tesla app and told my car to start charging. Swiping back to the Powerwall, suddenly 16 kilowatts was pouring out of my solar panels. I stopped the car from charging, and the erroneous solar production also stopped. 16 kilowatts is almost exactly what the app said my charger was delivering. So somehow the system thought the energy my car was getting was traveling in the other direction. My internet searches quickly revealed that I was not alone. Many other people had noticed nighttime solar production or something similar on their own systems. In some cases, like with mine, they were not able to get a resolution from Tesla. In other cases, Tesla or the installer came out and were able to fix the problem. I noticed that a number of people were giving the advice that likely their installer had installed something called a CT upside down somewhere in their system. CT stands for current transformer. It is a kind of electrical transformer that is designed for applications of measuring current. Transformers are incredibly interesting, and there's a lot more to them than meets the eye. I want you to love them as much as I do, so humor me here for a second. Transformers are the fundamental invention that make the world's large electrical grids possible, and they are the reason that our grids are AC instead of DC. Maybe I'll make a video about how transformers work, but at a high level, understand this. Transformers take AC electrical power at a particular voltage and current, and by using a coil of wire, or primary winding, transform it into an electromagnetic field. Then, using a secondary winding placed in that same electromagnetic field, harvests over 99% of the energy in that field and turns it back into electrical voltage and current in that secondary coil of wire. If the secondary winding has more turns of wire than the primary winding, the transformer steps up the voltage, and in order to keep the same amount of power, the current is reduced. If the secondary winding has fewer turns than the primary, the transformer steps down the voltage and the current increases. So a CT is just a step-up transformer that takes a large current that's difficult to measure and transforms it into a lower current that can be measured. And CTs are designed to just clip around a wire, so they actually contain only the secondary winding. The primary winding of a CT is literally just the wire that you're clipping it around. That wire becomes the single-turn primary winding. Genius. Alright, so a CT, when used in a metering system, is basically the first half of an ammeter, and the two wires coming out of it contain the transformed current that will actually be measured directly. That understanding should help us get our bearings when we open everything up. Based on that "your CTs are upside down" internet advice I found, I started to look for the CTs in the current path for my EV charger so I could flip them over. I started in the Tesla Backup Gateway to just get a general idea of what I was looking for. Based on the labels, it was very easy to identify where the solar production wires connected, this top breaker, and the wires from the solar came in from the bottom down here. The Powerwall batteries are connected through these bottom breakers. Okay, so this breaker bank on the left is where all the backup power comes into the system. I noticed nestled away back here that there was at least one CT that isn't clipped around any wire at all, but it does plug in up here into this connector marked CT3. Obviously that has nothing to do with the EV charger, since the EV charger was being metered, just backwards. So the EV charger must be metered by the two CTs that plug into CT1 and CT2. I headed over to the panel that had the breaker for my EV charger to see if I could locate the other end of these CT wires. Alright, here is the label for the breaker for car charger west wall, and here's the breaker itself. Let's see if we can find the CTs. Alright, here's that EV charger breaker, and yeah, the two wires that feed this entire bank of breakers have a number of CTs on them. The two that look like the CT I found inside the backup gateway must be the Tesla CTs. And the other two are the ones from Sunpower for their metering system. Alright, so we're just gonna flip these guys over and see if that fixes things. Again, it turns out that physically flipping these CTs is unnecessary because there's a way to virtually flip these in software. I didn't know that yet, and don't worry, I'll describe that soon, but for now, I was doing it the hard way. It's worth noting that flipping these goes against the label on the CT that says it should face the power source, but online forums indicated that at one point there was a batch of CTs that got labels put on the wrong side, so I was thinking that maybe that might have been the problem. I'm gonna set down the camera to flip the second one. So did this fix things? Well, for 3 months I kinda smugly and incorrectly thought so. When I charged my car, it showed as usage, as you'll see here. I had no more solar production at night. My usage history looked a lot more like a house with 2 EVs, but I still had frequent incorrect readings for solar production. My historical usage never showed any solar at all. My batteries still charged at unexpected and expensive times, and I was off when spot checking against my PG&E smart meter. So by turning my CTs upside down, the majorly obvious broken stuff was fixed. And for 3 months, I thought that maybe the other stuff was just maybe a limitation of the backup gateway. Actually, until I started making this video in August of 2024, I didn't discover the full extent of my ignorance. My CTs actually hadn't been upside down, and we're about to get into why it kinda helped, but was the wrong answer. When I make these how I fixed this thing videos, I try my very best to be 100% accurate about everything I'm explaining. So when preparing to make this video, I'm looking through manuals, service guides, learning about CTs, and even getting more rigorous about my understanding of residential electricity. It's a living example of the adage, if you want to master something, teach it. I don't know how many hours I spent watching Dustin Seltzer's Electrician U channel. It's super. Link in the description. That was one of the things that helped me finally untangle the root cause of what was going on here. By the way, I'm still open to learning, so if you see or hear something in here that isn't quite right, please comment. I won't be offended. I'm also really curious to hear what you found most interesting in this video. Do you find my dives into how Transformers work interesting or distracting? This is also a good time to remind you to like and subscribe. Alright, back to uncovering why flipping those CTs wasn't quite right. Remember this unattached CT we found nestled in the backup gateway connected to the CT3 port? Well, looking through the install manual for the Backup Gateway 2, it's clear that this was intended to be the way that solar was measured. Okay, so what wire do we clip it around? Well, based on the labels on the breakers, we know that the top two wires are the combined solar input. The manual says that CT3 should be installed with respect to L1 by default. An inspection of the backup gateway makes it look like the red supply wire is installed as L1. The CT has a label on it and says that the label should be towards the source, in this case, the solar panels. So, that's all the information we need. And here I am installing the CT on the red solar wire. But after all that, the Tesla app still showed no solar. In fact, it showed something more like my panels were using power rather than producing it. I was sure that this CT was not on backwards. What could it be? Well, given how these CTs work, if the CT were installed on the wrong phase of the solar wires, red instead of black or vice versa, it would look a lot like usage rather than production. This is because the red and the black wires coming from the solar are together carrying 240 volts when you measure between them. While one wire is pushing current, the other is pulling back and forth. But if you measure either wire against the neutral wire in the system that they're tied into, each individually will be carrying 120 volts AC, in a sine wave 180 degrees out of phase with respect to the other. Flipping a CT around on the same wire also does the same thing. The sine wave basically shifts 180 degrees, and current flowing one way looks like it is flowing the other way with respect to the reference voltage. So if the CT is on the wrong phase with respect to the reference voltage, this could happen. So I tried moving the CT to the other phase. This would be a great time to mention that physically changing this to the other phase is totally unnecessary because of the Tesla One app. The Tesla One app is intended for installers but is available to everyone, and you can log in via your normal Tesla account username and password, at least as of 2024. First, notice that for all the CTs, 1, 2, and 3, you can just flip them in software. So if that's your issue, it's a software fix. As for me, the critical feature it has for what I'm doing here is that you can configure CT3 to say which line or phase, L1 or L2, the CT is measuring with respect to. Rather than moving it from one phase to the other physically, you can just select in the app that actually, this is measuring with respect to L2, not L1, or vice versa. Much less electrocution-y. But I didn't know that yet, so here's the hard way. And suddenly, solar was working. My Tesla app showed the exact same production as the Sunpower app. But why? Well, here's why. After much multimeter searching, I discovered that the red supply line is not actually L1. It's L2. How? This breaker swaps phases right to left. Look, straight up through the breaker shows a 240 volt difference. That's what you see when measuring across the two different phases. And crossing the breaker shows no voltage difference. That's what you get across a continuous wire. I hadn't encountered a breaker that does this before, so this was confusing to me, but anyway, that explains it. But wait a second, could that have been the problem with CT1 and CT2 all along? Not upside down, but on the wrong phase? Let's go take a look. Every panel I've been in has the black phase on the left bus bar and the red phase on the right. In fact, you can see from the alternating black and red wires on the breakers on the left side of these bus bars that whoever wired these breakers in assumed the same thing. The top left wire is black, which connects to the first spade from the bus attached to the left lug. but we really need to verify which bus bar is the same phase as the red wire on the top breaker. The red and black wires connected to that top 200 amp breaker are what run to the supply lugs in the Tesla Backup Gateway and define L1 and L2. We need the Tesla Backup Gateway to agree with these bus bars as to which carries red and black for the reference voltages for CT1 and CT2 to make sense. Let's do some more voltage comparisons and figure it out. Yeah, this panel has been wired such that the red phase on the top 200 amp breaker corresponds to the left-hand side of this bottom bus bar, which is odd. Again, I expected the left side to be the black phase, and it looks like the Tesla installers did too. So that's the problem. And again, why flipping these CTs kind of fixed things, but the right fix was to swap the CT1 and CT2 to the other phase. Does it matter? In this case, yes, because unlike solar production, which is perfectly balanced between the red and black wires, these breaker panels won't have perfectly balanced loads on the two phases. There could be an appliance on the black phase that uses a lot more current than on the red phase. So these CTs need to be on the correct phase, with the label facing the source. So the installer hadn't installed CT1 and CT2 upside down, but rather on the wrong phase, and I can't really blame them because it's pretty odd to have the red phase on the left side of the panel. I can blame them for not testing their metering though. I reflipped these CTs and swapped them onto the correct phases. I'll spare you the video of that. You've seen me flipping CTs enough by now. And yeah, after a few months now running like this, everything seems fixed. Batteries charge and discharge at appropriate times. Spot checking the smart meter always shows the same usage as the Tesla app. Solar production matches between the Sunpower app and the Tesla app. So there you go. I really wish that I could have gotten Tesla Energy, who installed my system, to support it. This nonsense about Sunpower panels being the problem is pretty frustrating. As a recap of the actual problems we fixed here, in my system, CT1 and CT2 were installed on the wrong phases because my main panel was wired in a way the Tesla Energy installers didn't expect. CT3 was not installed at all. Although the Tesla One app gives you a lot of software options to tweak these, and I'm sure that fixes a ton of issues, in my case, we would have needed a site visit to swap CT1 and CT2 since their reference voltages can't be changed in the app. CT3 also required a physical change, namely to clip it onto the correct solar production wire. You saw that I did this myself, but for most people this would mean a visit from an electrician or your installer. I hope that those having difficulty getting support find this video valuable and can use it to help get a resolution. Thanks for watching.